afternoon. Can you hear me? Yeah. Good. I hope you guys had a good lunch. We're going to talk about containers. Apparently they're good for digestion. My name is Degioanni. I'm the creator and CEO of Sysdig. We have an open source command line system visibility tool called Sysdig and a distributed version called Sysdig Cloud. This is my second startup. My previous one was the company behind a pretty well-known network analyzer called Wireshark. So my background is in computer networks and performance from the network point of view. Containers are not only good for digestion, they are great for many reasons. By the way, how many of you are currently using containers? How many of you are looking into using containers? Yeah, it's quite insane. I like to ask this question to feel for the adoption of containers. It's really something that is happening today. So containers are great for a number of reasons. You know, they have less overhead than your typical virtualized infrastructure. They allow faster deployments, they allow reproducibility of environments, cost optimization, isolation, flexibility, all great features that all of us are, loving. On the other hand, monitoring containers can be a pain in the butt. Containers, some of the features that containers have, like they are isolated, they are self-contained, they are simple, lightweight and disposable. They also make visibility more complicated. And the big question is, can we achieve to have a great monitoring functionality but still respect these features of containers? And I found this picture that is quite a good example of what I have in mind. It's like we want to avoid being this guy, and you have your boat full of containers and you're watching it from very far away. It's very hard to understand what's happening, and at the same time you don't want to go and inspect every single container and walk into every single of them. So is it possible? That's the subject of my talk. So the talk is about an overview of what we have today in terms of container visibility, including command line tools, cAdvisor, the Docker API, and then I will spend quite a bit of time on Sysdig, which is the tool that I created, and it is behind my team. Most of the 30 minutes that I have will be spent in front of a console, so this will be very interactive. But don't worry, I have everything under control. I actually edited this picture 15 minutes ago when the VM that I'm using for the demo decided to crash. So I hope it doesn't happen during the demo, but if it does, be patient with me. And I hope I managed to restore everything. Let's start from some of the stuff that we want to monitor. This is a list of pretty useful stuff. It doesn't want to be fully comprehensive. I know there's more than this, but let's pick some examples and let's see what we can do nowadays to monitor stuff like resource usage, network activity, file I/O, and so on. Let's start from the first one, the first item in the list, resource usage. There are a bunch of tools that we're typically used to use for resource monitoring. Most of them work or sort of work for containers. So, can you guys read? Too small? Fine? Bigger? Let's try it. Better? Yes. What's the resolution of this display? 300 by 200. If we use a tool like Top, for example, One interesting thing, by the way, I'm using, my setup is essentially a virtual machine. I'm doing my monitoring. I installed with Docker a little WordPress infrastructure with a client container that is sending requests, an HA proxy, and then a bunch of Apache web servers, and then MySQL as the backend. And one interesting thing is that even when I'm running these, something like top from outside the container, I can actually see the processes that are inside the container, because containers are isolated through namespaces and C groups, but the processes that are inside the container appear if I do a top or a PS in the host machine. They just appear with a PID, which is different from the one inside the machine, because inside the container, because they get assigned their own, virtual PID inside the container, while they have an absolute PID number in the machine. And so here I can see, for example, all my instances of Apache running. The problem is I don't know which containers they belong to. One thing that I can do in top is I can add columns, and one of these, for example, is the C group 1. So if I select it and I go back, now I can see the rendering of top is not great on this resolution, but I can see the last column, C group, and this, no, I added group, sorry. C groups is, let's remove this one. Okay, now I have this C group string, which tends to be, quite hard to read, but essentially processes that have the same C group name are processes that are part of the same container. So I can sort of use something like top to determine what's inside a specific container. Of course, it's not the most user-friendly. If I'm using Docker, Docker gives me a bit of command line visibility functionality, so I can do something like the Docker PS, and they get the list of running containers, and then I can do something like Docker top WordPress 1, and this gives me something similar to a PS for the container called WordPress 1. One little trick is that Docker top supports PS syntax, so I can do something like, use the PS syntax to add columns or get metrics that just top PS alone that doesn't allow. So good, sort of limited. Let's take a look at CAdvisor. CAdvisor is a little tool. By looking at the command line that you use to install it, you probably get a hint of what it does. It maps a bunch of volumes in the host, stuff like envar or sys and so on, and uses it to export a user interface on port 88. So if we try to run it on a machine, it's actually already running. But once I have the container running, I can go to the local machine, try again, all right, and done. We have a nice user interface with Gojis. So, CAdvisor is a great option for local monitoring, especially because I can click on Docker containers. And by the way, CAdvisor doesn't only support Docker. For example, I can use it with LXC. But I have a list of containers running on the machine, which is very nice, and then I can click on any of them, and I get some, basic metrics for it. So CPU usage, memory utilization, network throughput, file system occupation, and stuff like that. So nice, presented in real time on the machine. If you want to run it if you want to observe it, with the web browser, very easy to install. Runs inside the container. The main issue is the metrics that I've shown you are essentially the metrics you get with CAdvisor. So containers are still, sort of black boxes, and you just get an idea of, what are the resource utilization from the external. Like there's no way to see what's happening inside, like in terms of processes and so on. A good thing about CAdvisor is it supports integration. So there are a bunch of them. For example, in FluxDB, Prometheus, and so on. So you can it's based on the API, so you can quite easily plug CAdvisor and use it, with a collection tool and pipe these metrics in a way where you can store them and see them later. Docker actually has an API, and it's the API behind Docker stats commands. So I can do from the command line something like Docker stats, with the name of the container. And as you can see, some metrics that are similar to the CAdvisor ones. I can actually create the simplest possible monitoring system based on Docker stats. Essentially, Docker exports its API by default on a Unix socket. So I can use netcat to send GET requests to container MySQL stats. So I'm getting out the stats for the MySQL container. And hey, here you go. That's all we need, right? Yeah. But this essentially gives you an example of and shows you what I can export. As you can see, it's slightly richer than CAdvisor. It's slightly richer than CAdvisor. I get metrics that are CPU related, network related, memory related, and also disk I/O. The URL on the screen gives you a pointer to where you can go and see the list of metrics that you can extract from that, and there's also a bit of documentation that's documented essentially by the Docker team. Pros of Docker stats, it's part of Docker, so you get it by default. You don't have to install anything. Well, you have to install something when you need to pull them, but the metrics are exported by Docker by default. The set of metrics is slightly richer than CAdvisor, so you can see more things. It's based on the REST API. It exports JSON, which is what I showed you. There are several integrations. For example, the link there is a GitHub project that converts these metrics into a collect plugin. There's also multiple vendors that consume this API to give you Docker metrics. So if you use an open source or commercial monitoring solution that exports Docker metrics, there's a very good chance that it uses this API. Problems with these, well, it's Docker only, so probably nowadays it's becoming less and less of a problem because a lot of people are using Docker, but there are other containerization technologies, some of which are established, some of which are coming up, like, for example, Rocket from CoreOS, and of course, with these other containerization technologies, this API doesn't work. And again, containers are black boxes, so this is something like a metric that exports you proc-like information for the containers, and so you only see what's happening from the outside of the container. Let's talk about sysdig. Sysdig is a command line tool that you can use to capture system events, filter them, and then run scripts on top of them. I often compare it to like a mix between strace, TCP dump, LSOF, and Lua. Actually, last week we also released a command line curses interface for it. At this point, it looks a bit more like strace plus TCP dump plus ftop plus htop plus Lua. The sysdig design goals are making it as simple and as lightweight as possible, so that it's possible to use it to monitor and troubleshoot production systems as well. Being able to tap into rich data, especially with containers, possibly much richer data than what you get with, from the examples that I gave you. Native support for containers, so the tool has been designed for container monitoring essentially from day one, including the ability to run from inside the container. And then, trying to have a workflow that is as natural as possible to expose these metrics in a way that enhance and help monitoring and interactive troubleshooting. How does SysDig work? This is a very simple example of a system on which you have containers running. You can have, of course, applications running on the whole system, and then you have a bunch of containers that are running on Docker or other containerization technologies. What we do is we install a little kernel module that sits at the kernel level and captures the interaction between the application, the applications and processes running on the machine and the operating system kernel. In particular, the main thing that we collect at this point is system calls. This information is collected by a command line tool, SysDig itself, which can run on the host or a container. In this diagram, it's running in the container. It can show you live information, or it can capture this information a bit like TCP dump or Wireshark do, so you can take trace files and you can analyze the trace files later. Let's go take a look. So, SysDig, when you run it from the command line, oh sorry, let's go to the other one. When you run it from the command line, gives you this very useful output of your system information. I told you it's all you need for monitoring, right? your information is all there, actually. So we try to do a couple of things. First of all, from the command line, we try to expose again. I'm coming, from computer networks, so we're trying to expose a TCP dump like filtering syntax for this. So I can do something like file descriptor.port equal 80. And at this point, the information is starting being a bit more meaningful because I'm filtering only for essentially the activity that is happening on file descriptors that are resolved to be sockets and sockets on port 80. So there's quite a bit of logic to make this work. And of course, filters are composable, so I can do event.buffer contains for example, get, and at this point I only get, the get requests happening on port 80 on this machine. Notice how, since we sit underneath the containers, you can see this information for all the containers. You can also run scripts if you want on top of that. The thing that I want to show you is the user interface that I was talking about before, which is called SysDig, and as you can see, this looks a lot like HTOP. I love HTOP, it's one of my favorite tools. So when we started building this, I tried to mimic the user interface of HTOP. And this shows you essentially the CPU occupation and CPU memory and file and network occupation of different processes running on the machine. As I was telling you before, you can also apply to a trace file. So now I'm doing the same, but essentially this is a file trace that I captured, like yesterday on the same system with a similar setup. A couple of differences between these and your typical HTOP. The first one is the ability to support views, which, by the way, is configurable, so you can create your own ones using filter fields. Right now I was looking at processes, but I can look at the network connections on the machine. I can look at whatever system calls happening on this machine. I can look at something like the directories that have the most utilization. The other interesting thing is the ability to drill down. So I can make a selection and I can click enter. For example, this is a directories view, and I can see how many bytes are being read and written to a directory. I can click on a specific entry, I click enter, and I go inside the directory, and now I'm seeing the files inside the directory. That's essentially done by creating filters on the fly, SysDig filters to screen the information that you're seeing on screen. All right? Now, container support. I'm restarting SysDig with the PC flag, which stands for print containers. As you can see now, we have a bit more information on screen. For each process that is running on the machine, we not only have the PID, but we also have the VPID. So for example, you can see that MySQL has a PID outside the machine, which is like an incremental PID, but inside its own container, it's starting with PID 1, which is a really useful piece of information that for the moment is not returned by tools like TOP or PS. We're discussing that with Brendan before, which is probably coming soon, hopefully. But the internal PID is useful because typically like process logs stuff indicating its own PID. So what's really interesting when you're looking at logs, usually it's the VPID. And then, you know, in addition to memory file, network activity and so on, there's also a column for the container that this specific process belongs to. Not only, but I can, you know, go and switch to a view, for example, the container view, and here again, you know, I'm seeing essentially the list of containers that are running on the machine and some resource utilization, including CPU utilization for all of them. Again, one nice thing about sysdig and sysdig is I can drill down, so I can pick, for example, the WordPress container, click enter, and now I'm seeing, you know, my Apache instances running inside the specific container. I can go back and I can pick another one, and you know, I can do this both on the trace file and in real time. Make sense? Network activity. I can use CAdvisor and Docker here to at least get the overall network traffic generated by a container, but that's where they stop essentially. So how many network bytes the container is doing. I can definitely install, you know, stuff like TCP dump or T-Shark or IFTop inside the container. At the point I can attach the container and either use these tools interactively, or I can take a trace file and then I can take it out of the container and analyze my network activity on the container. I can also use sysdig. So if I go back to my containers, for example, I can go to the HA proxy container. And the nice thing about sysdig is, again, you know, this works all from outside the container, so I don't need to instrument the container. I can go to the HA proxy container and pick the server ports view, and I can see that, you know, most of the traffic here is expected is on port 8. One other thing that sysdig can do is, if I click on the echo button, I'm looking at the activity on that specific port. So let me actually go and convert it into printable ASCII. So I'm seeing the requests and responses that HA proxy is doing on port 80. And this is done again by collecting the events, looking at the reads and writes that the HA proxy is doing, and sniffing them and presenting them to screen. Now, these are all the requests on this port, but I can drill down, click on the port, and then click on connections, and now I have the list of every single connection on the port. I can, again, you know, look at it, and now I see the request and response for that specific connection, but I can also go back and click on the tick button or F6, and now I see the specific activity that happened, that HA proxy made on that connection. So connecting the send to, including the buffer, and then the receive, and then, you know, down to when the socket is closed. So this is like probably not something that people will do on a daily basis, unless you're Brendan Gregg. But it's something that can be useful when you're troubleshooting stuff, especially if you can do it from outside the container without having to instrument the container. Let's also take a look at what can be done with sysdig from the disk I/O point of view. So similarly, in file activity, I can pick a container like WordPress, and I can click on directories, and now I see that disk activity for these specific containers grouped by directory. I can, for example, go, you know, under etc, and I can see which file has been accessed by that container under its local etc, and it's the host file. Again, I can, you know, echo it, and I see what's been read from /etc/host inside the specific container. Or I can maybe start from error. So I go back to my whole traffic on the machine, and I can pick something like the errors view. This is a bit more cryptical, but essentially what I do is I collect all these events from the processes running inside or outside containers, and I extract the return value from them, and then I print them on screen. Inoent, by the way, means file not found. So I can drill down into it, I can click into it, and I can see the processes that are generating this error and which containers they are on. So one is MySQL running in the MySQL container. The other one is this little process called API server running inside the host. I can dig inside this specific activity, and I can see, the file logs /applog.txt that has problems while opening. So this is probably, either the directory doesn't exist, or it's read-only or something like that, and gives me an indication of something that I can fix inside the specific container. Make sense? Topology. So I want to show you a couple of things. Actually, where is it? Unfortunately, the network connection codes are not helping me here, probably. Maybe I'm lucky. This is CZ Cloud, our software as a service tool. So I want to show you a couple of ways we collect this same information to do interesting stuff for containers. So this is a CZ Cloud view of a similar infrastructure-based container-based infrastructure. I can see that I have 3 web server machines, each of which is running containers, and I can go, into a specific container and get, for example, something like the list of the count of requests for the specific machine. And of course, we can do this in real time, or we can do it historical. But I can. What we do is we collect this information from underneath the container, including decoding the protocols. So, for example, I can segment these by URL, and now I see the number of requests by URL. Again, without having to instrument the container at all. I can do that for the specific container. I can do that for the whole machine that has these containers, or I can do it for a tier, so for a group of machines that are identified by tags or stuff like that. The other thing, and this is the last thing that I wanted to show you, is the map overview. So this is a different way to see the same infrastructure. What we do is we collect the traffic, we detect the activity among containers, we bring this to our backend, we stitch things together. And here, for example, the same tier that was running WordPress, I can see it as front end, and I can see that it has 3 machines running inside of it. So what I can do is I can zoom in it, and now I see the 3 machines that are creating this tier, right? I keep zooming, for example, instead one of them, and now the Docker containers, let's pick the one in the middle, for example. The Docker containers start appearing, and I can see the interaction. Actually, I can also click play, and I can see the real-time interaction that is happening inside, and I can see the HA proxy container inside the machine talking to the WordPress containers and so on. I compare it a bit to Google Maps for your infrastructure. I can keep zooming in, and at this point, as you can see, the containers explode, and I see the processes that are running inside the container. And for example, in the HA proxy one, I have a little script in Python that is calling HA proxy, and then HA proxy is talking to WordPress inside the other container. So this is, ways to use the advanced information that we collect from containers to create interesting visualizations. I think I used all of my time. So yeah, thank you for watching my presentation. And I will be around, of course, so if you want to grab a beer with me, I'm really good at drinking beers.